Yeah, I think this is going to be a shorter theory portion, and yeah, I'm going to do the exercises for chapter 11, but not supplementary ones because they're taking me some time, and I want to start topology quite quickly. So let's start it already, and yeah, so we'll start topology, proper topology, right after this, and yeah. So it's going to be a short theory portion. There's not much. I'm just going to state the principles. So for any collection of sets with a strict partial order, and a partial order is essentially an order, a strict, a total order, but without the totality. So yeah, it's transitive and non-reflexive. And for any strict partial order, we have a maximal simply ordered set. So if it's maximal, essentially you add a single element to it, and it will no longer be a total order. That's it. Yeah. And maximal means it's also like you can't add it. That's all. And Zorn's lemma is uh yeah, Zorn's lemma is if you take a selection partial order again, right? Strict partial order. Okay. And if a subset of B, which a subset happens to be simply ordered, then and if it has an upper bound in A, then it there exists a maximal yeah, it's not, what is it again? Yeah, there exists a maximal element of B, and the maximal element is, yeah, basically M A does not hold. So so M is greater than equal to A for all A in yeah, A these have to be the ones it can actually compare with. So this doesn't hold doesn't mean that it has to hold for all A necessarily, right? It's only in the chain. They're also called chains, by the way. So yeah. So okay, so in a simply ordered set, we choose the maximal simply ordered set from the maximum principle, and the maximum element, the maximal simply ordered set has an upper bound by assumption, and that upper bound itself happens to be the maximal element here, essentially. And that's because if C does happen to be less than D for anything, then B union D is also simply ordered set. So yeah, that's pretty neat. So maximal, Hausdorf's maximal principle implies Zorn's lemma, and for the other one, we'll solve it in the exercise, but supplementary later. Yeah, as I said, pretty short.